Hi everyone, welcome. Today we are going to be looking at exponents and some of the ideas that exponents are used in advanced mathematic questions. It is often showing up in a lot of different places, but in terms of number theory, it comes out a lot in multiples. And so we're going to be looking at some of that. We're going to be establishing some of the basic principles when it comes to these ideas. And then we're going to be looking at some of the difficult questions if you are in the advanced math club. Yeah, so let's begin. So today we're going to be talking about and their multiples. Okay, let's look at first of all what we're going to be looking at today, what exactly we're going to be focusing on. So the idea basically that we're going to be looking at is are questions like these. So for example, if you have a number like, let's say 7 to the power of 25 minus 1, and then you want to divide this by, let's say, a number like 7 to the power of 14 minus 1. How would you do this question? Is it even possible for you to figure this out? Some people would begin by saying, oh, well, if I put x as 7, then it's 7 to the power of 25 is this. And then, like, in case of more inexperienced students with these kind of questions, they're like, how do I even do this? Do I have to do this whole thing where I go, well, that's this, and then I go all the way to here, and then I start plugging it in? How does this even work, right? So we're going to be looking at those kind of ideas. And so before we can look at actual question like these where we have integers in here, let's look first of all at how we can solve theorems, equations like these with x in them, and we can just directly translate that over to use of integers. Yeah, so let's look at this first of all for today. Let's look at how x is used in number theory. Okay, so in questions like this, we can think of it like this. So let's say, again, let's change the numbers up just a bit. Let's say I want to do this. And then I want to say, okay, this is x to the power of 3 times something plus something. And this is the remainder. And this has to be smaller than x to the power of 3 minus 1. Okay, then how do I do this? Well, the basic idea is you want to think about what you're doing when you're multiplying to numbers here. So let's say this number is made up of something like a plus b plus c. Because normally when you use the binomial theorem, for example, this is the kind of idea you end up with. You'll, when it's like x to the power of 3 plus 1, you're going to end up with something like this, and then something like, I don't know, something like this, and then something like here. And so let's just say it's a plus b plus c. What would happen if I timed a plus b plus c? Well, okay, let's try this out. A to the power of 3 minus a, and then b to the power of 3 minus b, and then c to the power of 3 minus c. Okay, what does that mean? Well, normally a is bigger than b and b is bigger than c, right? And so, I think we're basically doing this. And then since we have this here, we want to cancel these together, and then we want to cancel these together, and then we want to cancel this with the remainder. Now, I know you're probably thinking, oh, what kind of crazy talk is she thinking? But let's just look at it in real numbers. So let's just directly translate this over to our question. So when we're doing a question like this, what we can think is, first of all, how do I make the number that is right here? How would I make this number using this? Let's look at it from the very front. How do I make x to the power of 3 equal x to the power of 14? Well, I would have to multiply x to the power of 11, right? Because x like this equals 3 plus 7, 11, and it becomes this. So, okay, so I'll do that. And then what happens if I do that? Well, I would get, just from this, I would get x to the power of 14, but I would also get x to the power of 11. Okay, but that's not the equation I want. Okay, so I'll figure out a way to get rid of x to the power of 11. How do I make x to the power of 11? Well, if I want to make it with x to the power of 3, I can just say x to the power of 3 multiplied by x to the power of 8. So I'll just add that. And so this whole thing, this thing, just gave me x to the power of 14 minus this plus this minus this. Do you see it now? Do you see that when you add these numbers, you can cancel out the negatives and get closer to the equation that we're trying to solve? Let's look at the next numbers. Okay, so now that I have, now that I have this x to the power of 8 that I do not need, what I can do again is the same thing. How do I make x to the power of 8 with x to the power of 3? I just add x to the power of 5. Okay, and then when I look at this whole thing right here, I would just be getting x to the power of 14 minus x to the power of 11, this, and then let's see, this, and then this, and then this, and then this. Oh my gosh, okay. And so I can cancel these two out. I can cancel these two out. Oh, wait a minute. What just happened here? Oh, I don't think we have done that yet. Yeah, so these cancel out, and what I'm left with is x to the power of 5. Again, this repeated pattern. So I want to make x to the power of 5 by doing x squared. Okay, if I do this whole thing now, let's get rid of some of these. Let's see what happens when I do this whole thing. Okay, x to the power of 14. I'm doing it this way, guys. This, and then this, and then this, and then this, and then this. That's the kind of idea here. But if I do x to the power of 14, it would be this. And then if I do it here, it's this. If I do it here, it would be this. If I do it here, it would be this. If I do it here, it would be this. If I do it here, it would be this. And then if I do it here, it would be this. Okay, now that I have this, how do I get rid of that? Well, you can't really time it to, you can't really do x to the power of 3 times something to make x squared, right? Because then it would no longer be an integer, and we're looking for integer numbers. When you are looking at dividing a number or dividing an equation, you want to keep everything as an integer. And so you have to say, oh, we can't continue like this anymore. Then I got to just do this and then write this out here. That makes sense? And so basically what we did just now is we figured out a way to get these all assembled and in order to make this. So we cut this out, and then we said we want to look at this, right? And then we did this whole entire equation just to say x to the power of 14 plus this, and then x squared. And this comes directly from here. And so if we were just to cancel all these out, we would just get the number we wanted. And so this is the way you would do it. And because we have this -1 at the end, we can just add -1 on both sides. And then this would be the quotient we're looking for. This would be our remainder. And yeah, that's basically how this whole thing works. And now, I know you might think this is very, very difficult, but trust me, it's actually not. And if you continue to familiarize yourself with it, I am sure you can eventually grasp it. It just takes a lot of practice and a lot of repetition. Okay, let me try with a different number. I will try to keep this as concise as possible, but still deliver the same kind of ideas. Okay, so I want to do 18 minus 1 quotient. Here, we'll just call it big Q. The remainder here, we'll call it large Q. And again, the remainder has to be less than this. Okay, what do I have to times to x to the power of 18 in order to make x to the power of 63? Well, that would be 63 minus 18. What is that? Is that 45? Yeah, so that would be x to the power of 45. And then, again, if I do that, that gives me x to the power of 63 minus x to the power of 45. And I want to get rid of this 45. What do I have to times to x to the power of 18 in order to make 45? Well, I need to make x to the power of 45 minus 18, and that's 27. And so we put 27 in there. Okay, I put x to the power of 28, 27 now. What do I get from this whole thing? Well, I get x to the power of 63 minus x to the power of 45, x to the power of 45 minus x to the power of 27. Okay, I just got that. I want to get rid of x to the power of 27 now. What do I have to times to x to the power of 18? I'm basically mapping, but it's the same idea. So it would be x to the power of 27 minus 18, and that would just be 9. And so x to the power of 9, and this whole thing would basically give me x to the power of 63 and then x to the power of 9. And then you realize I can't really time anything to x to the power of 18 in order to get that. So I just better put it outside of this, outside of the brackets, because then it would no longer have to be multiplied by x to the power of 18. And so I would just do this, and then that would just give me x to the power of 63. Shall we look if it really does? So let's try it out. X to the power of 67, 63, 45, 27, 9. Again, this comes out from this number. We just translate it here. And then because these all cancel out like this, we do get this number. And so if we were to make this, we would just have to do x this, and then we would just get and then x to the power of 9 minus 1. Okay, that makes sense. That's pretty okay, right? That just gives you an idea of how this works, and that is the quotient, and that is the remainder. And again, check that this is less than x to the power, and it is. It really would depend on the constant if we were to say that x, is a variable. But in this case, just think of x as a random shape. So you're trying to say how many shapes could fit in a place, if that makes sense. So 18 of x, 18 to the times of x would not fit in here. Just think of these numbers as the number we're looking at. Yeah, okay, so this is our basic idea. And now let's translate that over to this question. Just this is the easiest part. You've gone through the hard part, and now you are at the easy part. You change x with an integer, and it would have the same effect. Okay, shall we try? So translating that a bit down here. Let's look at this question. Okay, so same ideas, guys. Just think of 7 as x. 14. Okay, so let's say that x to the power of 25 is equal to this times a quotient plus a remainder. And again, smaller than this. Now let's try to solve it. Same idea. So what would I have to multiply to x to the power of 14 to make x to the power of 25? It would be x to the power of 25 minus 14, and so that would be 11. And then from this, I would just be getting x to the power of 25 minus x to the power of 11. Okay, that makes sense. So is there any way I can get rid of x to the power of 11? Well, I have to times x to the power of 14 in order to get that, right? So how do I make this into 11? Is there anything that can go in this place to do that? I don't think so. It would have to be something like this, and we're only looking at integers. So no. So we close the bracket, and then we say, we'll just add it outside of here for you. And so this whole thing would just give you x to the power of 25. And so this would be, x to the power of 25. Okay, so in order to get x to the power of 25 minus 1, it would just be this plus x to the power of 11 minus 1 because you just added that. Okay, and so after you've done that, you just have to change x with 7. Shall we try? So just moving this down a bit again. Yeah, so let's change x with 7. We would just get 7 to the power of 14th, 7, and then 7 like that. And that is basically how you do it. You thus use exponents and their multiple in order to make these. And it's quite simple, right? If you are in the beginner chess club, this is as far as we will go with this because this is quite an advanced idea. And I would recommend that you try this question, but with different numbers. So you could try, for example, numbers like x to the power of 25 minus 1. Or you could even get rid of the minus 1, right? You could just do this. And then I wanna do something like this. Times something plus r. How would I do this? Well, hint is you can translate this to the power of something, this as well, 2 to the power of something, and then you can go on to solve this. Yeah, and so that is the basic idea for beginners. If you are more of an intermediate, I would recommend that you watch the next video on this topic where I will deal more extensively about the advanced ideas and the advanced questions that can come up with this. And yeah, I am so thankful that you are here with me to listen to this and that you were able to understand what we did today. If you have any questions, just email me, send a picture of the notes you wrote and then highlight the places that you don't understand, and I will get back to you and try to explain it as best I can. Yeah, guys, thank you so much for watching, and I'll see you next week. Bye bye.